Our last part is negating nested quantified expressions. And the good news is this looks very similar to what we did when it wasn't nested. We're going to do the exact same thing. So the only interesting part is that we're going to be able to this is familiar too, where we have to do our switch of our symbols and then we push off our negative into the next part of the formula. And that's again because of De Morgan. So just doesn't happen by relation. This happens because of a law well, frankly, because of De Morgan's. So again, our overall steps at the very end, we may be able to switch a symbol if we're given the actual predicate function itself. And again, we're going to use the overall steps using De Morgan's that you've seen before, now just with nested instead. So in this example, if I've asked to go ahead and negate this overall, well, equation here, so we're going to go ahead and put a negation in front of that. So what we're going to do in part two is we're going to slowly break it down by De Morgan's on ended up switching up our symbols, and then at the very end we're going to go ahead and negate the innermost sign of our proposition if we're even given that. So just a heads up, because you'll see another couple examples you may not. So anyway, so first we're going to change this negated universal quantifier to our existential, but we got to pass on that negation. Notice I haven't touched the rest of it, just the negation and the rest of it. And notice I did that by using De Morgan's for our universal. Then we're going to do the exact same thing. I'm going to change this to, well, just the flip of it, negated, and we push our negation into our overall equation. There's nothing left back there. But again, we're using De Morgan's for an existential. And then finally, at the very end, we had, well, negate that is make it real easy. X of y does not equal 1. Negate the most innermost sign, and then that's about it. So for part three, we're going to, well, basically turning it back into English. There exists an X where for all y, where X times y does not equal 1. So that's the overall set negation for that. And that kind of makes sense from what we had up here, right? So it should at least make sense. It's negated. So that's example number one. Example number two, notice we're actually not given, well, we're given part of it. Part of it has a symbol and the other part does not. Okay, so just heads up with that. So we're going to go ahead and negate the whole thing, and very similar to last time. The only thing I did different on this one is I made sure I put parentheses after each time that I moved back. You don't have to do that, but I did on this one just to kind of show you what I've seen from other people as well. So anyway, I went ahead and flipped our negated universal into our existential. Then we have our negated portion right here using De Morgan's. You see De Morgan's, and here we go here. Anyway, so then we're going to go ahead and now flip the existential to our universal, and the negate, we're just moving that negation back. And now here's where the interesting part is that now I can go ahead and negate what's inside, and what is negation of a less sign or equal, when it's just greater, and then we just have our negation for our P of X. So still, works out all right. Now, the funny part is that in reality, that last part, if they really didn't want to have a negation symbol in there, this actually fits the form of one of our values. Remember CDE? So that ended up, we really could end up having this one for our having a negation replaced with an implication. So fitting one of our rules that we've gone over. So just food for thought for that. And here's example number three. There really isn't any difference in what you've seen before. These aren't too hard, thankfully. So I'm going through, doing our De Morgan's for first our universal, second our existential, and then we finally get to the end here in X of y. We had it originally set to equal, and it's not equal to 1. Very simple set when it comes to that. And again, when we spell it out in English, it should sound just the opposite of what we had and what we were given originally. Finally, I want you to go ahead and do one last problem here for this set of notes. So take a look at it, go through it. This one shouldn't be too hard. Please use the table setup that I've given you for this. I did that on purpose so to frankly make it easier on you. So have at it, and we'll go over and answer here in a second. Hopefully this one was simpler for you. Part one is going ahead and just negating what we've got. So now that we've got part two in negation, we're going to start doing our dance with De Morgan here. We're going to go ahead and switch our overall universal to an existential, pushing back our negation because we're using De Morgan, pushing it back further into our universal. Now the negation is part of the equation itself. And then negating that innermost sign is the last part of that. And again, then really kind of make sure you kind of spell it out for yourself too. Read it out and see if it makes sense to you and that really what it's doing. If it does, then hey, you got to at least be close. So still, nice easy setup for this. Again, please notice I'm showing the work for each one of these. I need you to do the exact same thing when you're doing your homework or whatever. And that's why I'm trying to make this easy and hopefully explaining it out to you what's happening.